My name is Joe, and this is Sierra Specialty Auto. Back when I was running my brake cylinder sleeving business, I had a customer who would every couple of 3 years ask me to make him some push rods for MG Midgets and Austin-Healey Sprites. And he's run out now. It's been quite a while since I did any. He asked me if I would be able to make him some more, and I told him sure. Over the years he became quite a good friend, and still a good friend. I like doing favors for friends. So let's take a closer look at what we have to do, what the difference is. For those who might be interested, I'll explain a little bit about why we have to do this. This is the type of cylinder we're dealing with. It's a dual bore combination clutch and brake. Brake on this side, clutch on this side, with a common reservoir. It was made in two sizes, MGAs and some other British cars, along with early versions of the MG Midget and Austin-Healey Sprite, which are collectively often referred to as Spridgets. That would be the 948cc engine with drum brakes. All those cars used a 7/8 inch piston, and in a later version of the Spridget, the engine size was increased to 1098cc, and the brakes were changed to disc brakes. The disc brakes required a smaller piston to develop more pressure, so a 3/4 inch piston was used. And not only is it an 1/8 inch smaller, it's also 100 thousandths of an inch shorter. Let's see if we can get that to show. There we go. It's I've got the one end held flush, and I hope you can see. Can I get that? That there's no, I said 50 thousandths of an inch difference in length. And the third difference is the length of the pocket in the end of the piston for the push rod. If we put the push rod in to the 7/8 cylinder, mark it with a thumbnail, and then feed the 3/4 piston on, we see that there's a 1/2 inch difference in the depth of that pocket. And so the push rods are, that's hard to get to see that angle that's required to show that. The push rods are a 1/2 inch shorter. Now this push rod, and these are made out of 3/8 inch hex. That hex is the original profile of the material, and then they're turned threaded ball end on one end. This 948 length push rod is readily available from the normal part suppliers. Moss Motors and others carry this as a replacement part. So far, none of the vendors are carrying a 1098 version, a 1/2 inch shorter. They tell their customers to buy the longer one and cut it off. So my old customer years ago had me start making these for him to the correct length, and we get them plated, cadmium plated, so they look good, and we supply them with a proper jam nut, a thin hex nut, as per original. And this job gives the opportunity to demonstrate the use of a couple of special items of tooling that may not ordinarily be encountered, especially in a typical home shop. But a lot of guys who are doing any kind of production work, including some in a home shop, are using these tools, and so maybe somebody will be interested in them. I'll get some of this stuff organized and out of the way, and bring out bring out these two items of tooling. The first thing I use, and this is set up on a boring bar holder, this is called a box turning tool. These are bearings here, little roller bearings, adjustable, and this is a box turning tool. It's a specially made turning tool, and I don't know if I'm going to get it where the contours of that tool show well. Even if I take it out, I don't think it's going to be easy to see. I'll just turn it and we'll hope it shows up. At any rate, you feed material into this tool. In this case it'll be hex stock, and we'll start with a chamfer, a pretty good chamfer on the end of these pieces. They'll be cut to length just like this, except hex all the way, and that will register well enough to carry this tool in, and by the time it comes out we'll have turned it down to the desired depth, to a diameter of 5/16. Then we'll repeat that on the other end, and the other end will get threaded 5/16, 24. Yep, 5/16, 24, fine thread. The threading will be done with a geometric die head. This is a small one. This may be the smallest one they make. I've got a couple of larger ones, but this one tends to stay set up for the job. You preload this by turning the body, and it clicks, and you set this up with a stop on the tailstock. Usually I use the carriage as the tailstock stop. And when it stretches out, it releases, opens up the die chasers, and releases the work. And when this is properly set, it will make very good threads, as close as you care to set them, and it is adjustable. There are a pair of small machine screws that turn this left and right as an adjustment to set the class of thread. And I've got this set probably to about a number 3 class. And this is a marvelous production tool. This is the type of thing that would be used on a turret lathe. Of course, nowadays with CNC machines that would be done in a different manner, but there are still a lot of people making a lot of parts in turret lathes, and these geometric die heads are an integral part of that. So let's first get our raw material, which I buy from McMaster Car in 6-foot lengths. This is 12L, or excuse me, not L. This is 1215. Has sulfur and phosphorus, so it's free machining. It does not have lead. I have in the past used 12L14. It works very well. We're going to try this for the first time. So I'm going to go off camera and get these two 6-foot pieces parted up into a bunch of roughly 3 3/4 inch pieces, which is the length of the stock we need to make each push rod. Here's the piece installed against the, or clamped against the stop in the collet. There is quite a bit of stick out. Ordinarily wouldn't be comfortable working like this, but we're going to be doing very light cuts, and this material machines very easily, so this has worked fine for me. we see a little bit of wobble making the chamfer, but it doesn't squeal, and if I'm careful, it doesn't bind up. I have all of my pieces of stock faced and chamfered on both ends, cut to length. So now I'm ready to go on to the box tool, and I have a leftover bit that was 1/8 of an inch too short that I keep in my toolkit to use as a guide to line up the box tool. I'll see if I can get a picture of what I'm talking about here. Since this is the size that we're going to cut, it should line up well with the roller wheels and with the cutter. And that picture I've put in there should show pretty good alignment. So let's take this guide out, put a piece of stock in, and we'll be ready to make our first cut. This needs to be a cut of 2.5 inches. We need to take this down to 5/16, 2.5 inches from the end. So I'm going to bring the box tool flush to the end and set my carriage stop at just under 2.5 inches, and we'll fine tune after we get in there using the micrometer adjustment on the carriage stop. Well, let's see how we did. We're looking for 2.5, and we have about 1/16 of an inch shy. That's what I was expecting. Get a little bit more. All right, I think I need about another 10 thousandths. Polish that lightly with some 100 grit, and that part's done. Nice 5/16 diameter, the exact correct length. We'll finish up 35 more of these. Then when we get ready to turn end for end, we'll have to put a 5/16 round collet in there, and then I can start working without shutting the lathe off. The right tool for the right job. I'm ready to move on to the next operation. We'll switch over to a 5/16 round collet. I don't need a stop this time because my shoulder will act as a stop. So let's get this collet in and get started on the next cut. I have the focus a little back on the chuck because when I try to focus on the work, that it keeps fluctuating. It can't hang on to that small area. So we're biased a little bit toward the chuck with the focus, but that had to do that to keep it. So let's see what kind of cycle time we can get out of this. The next operation is threading. I'm just about set up here. I think I need to do a little fine tuning on the depth. I have the carriage set as a stop for the tailstock, which has the tapping head in it. As the tailstock moves towards the chuck, the threads will the tapping head will begin threading when the tailstock hits the carriage. The head of the tapping head will continue to travel with the threads as it. Let's see if I can do this by hand. It will pull it. Will pull the tapping head into the threads and release the die head. At that point, the chasers are open, clear of the threaded part, and then you can pull the tailstock with the die head back. And I think I'm going to be a little bit short on the threads, so I'll have to adjust the location of the carriage and then just run the die head on again to finish the threads. And I'm at 510 RPM. Probably could be faster, but this speed works for me. Just push it in, let it grab. There it's, all right, now we see I'm a little bit short, so I'm going to adjust the carriage stop, reset the die head. That looks about perfect. Just doesn't get much better than that. Well, Maybe it does. I could maybe get another 1/16 of an inch. Let's try that. Let's go 50 thousandths. Don't want to get carried away. If you go too far, you end up binding at the end of the travel, which is not a good thing. Right there, it bound up a little bit. Yep, that was too far. We need to come back some. So this is no longer a perfect part. I went too far and it dug in. So we're losing a part there. Don't get cocky on this. Take what works and leave it at that. That's what we need. That's pretty good. I'm very happy with that. Continue through and do all the rest of these at the same setting. In this application without flood cooling, the box tool sometimes leaves some tooling marks on the shaft. On the threaded side, they disappear in the threading. But I usually pick out the worst ones and do a little filing with a long angle lathe file and hit them with a 100 grit abrasive paper. So maybe half of them get this treatment. For the final machining operation, we're back in the 3-jaw chuck. My 3-jaw set true chuck and my other non-adjustable 3-jaw chuck both have a gap in the teeth of the jaw about 1.5 inches back that will accommodate the hex, the remaining hex, so that I can chuck up on the 5/16 diameter. And I need to radius the end of each push rod with this radius tool. Running again at about 510 RPM and just a hand feed operation. Have to be a little gentle because with this tool, that's a fair amount of stick out and it wants to chatter if you don't go carefully. But it's easy with just a little bit of handwork to get a nice rounded tip on that. last thing I need to do is knock the sharp edges off of the hex. I'll do that on the filament abrasive wheel. All of them will get this treatment. The brushing operation also gets any slight burrs remaining from the threading. There is the finished product. I started with 36 blanks. I lost 3, or about 12 inches, 1 foot. My delivered cost, including transportation, for 12 feet of this material was right about $30, so that cost me $2.50, mostly to my own carelessness and in the setup process, not paying enough attention to what I was doing. But we ended up with 33 out of the 36 ready to send off for CAD plating, and then they'll be ready for my friend. There's another job finished in a reasonably satisfactory manner, so let's wrap this video up. I hope you'll comment. If you haven't already, I hope you'll subscribe. I hope you'll come back and visit the shop again. Thank you for watching.